Hello everyone, today I will be talking about round 724 Division 2 F. And so basically, this problem we have two players. The first player is Akmar and the second player is Omkar. So how it works is that you have some sort of board in a circular pattern. So for example, if the board of size 6 will look kind of like this, where these circles are all empty cells. And how it works is that every player, when during their turn, can play either an A letter or a B letter in one of the empty cells. And the rule is that you can't play the same letter next to into a cell that is adjacent to a cell that already has that letter. For example, we can't play A here. This will be illegal. And so that is the only restriction. And so here a valid move would be like B here, or you could play somewhere totally else. So you could play A over here, and then now the rule is the player who wins is the player who loses is the player who doesn't have any valid moves. So if the player in this position were to go B here, the next player will not have any valid moves because you can't play A or B here or A or B here, which means that the player who played this last B would win. And so the question asks, how many possible valid games are there in a board of size n? So you're given n and you have to tell me how many valid games are there where both players play optimally. And by optimally, I mean that neither player decreases their odds of winning, assuming the other player also plays optimally. So that's basically the problem. And so now I'll go over the solution. So the first thing to notice, and this is a pretty big thing to notice, is that you should realize that the second player always wins. And the reason why the second player always wins, and the easiest way to notice this is by considering ending states. So, and also the implication of the second player always winning is that since no matter what the players do, the second player will win, the number of optimal games is also the number of games total. So, and anyways, to show that the second player always wins, we can consider a few things. So say you had two cells next to each other, and they were both filled, then you know that they have to be different. So A or B or B or A. And say you had 3 cells next to each other, and the 2 cells on the end, and pretend that, for example, there's a lot more cells, so it's not like a board of size 3. And say the 2 cells on the ends are different, so A or B, then you can't have anything in the middle either. And so basically what I'm trying to say is that if you were to ignore empty cells, you have to have some sort of pattern like this, where it goes A, B, A, B, A, B. And you can't ever have 2 cells next to each other that are the same letter. So for example, if you had AA and then like A, B, A. So there are 1 or 2 things that happen. First is that there is no cells in between. So for example, if there were no cells in between, then this would have been an illegal game because you can't ever play the same letter. You can't ever play a letter into a cell where the adjacent cell has the same letter. So you would never have the situation where you have 2 letters that are the same letter in adjacent cells. So the other situation you could have is 1 or more cells in between. And this is also not a valid state to end the game. And the reason why is that there's another possible move, which is to play a B in the middle. So as you can see, you have to have this kind of alternating pattern if you were to ignore empty cells. And additionally, in between each A and B, there's 0 or 1 cell. So everywhere here, there is 0 or 1 cell. So the more important part to notice is that if you alternate A and B, then you are guaranteed to have an even number. You're guaranteed to have an even number of turns. And because there's an even number of turns, the next player, after you play an even number of turns, will be the player that played first. And so this means that no matter what the second player does, he is guaranteed to win. So that's because every ending state has an even number of letters. So, given that, and if you would have an odd number of letters, which means you had an odd number of turns, then you're guaranteed at some point to have two letters that are the same that are next to each other. And so, as I just mentioned, that is not a valid ending state. So there's no ending state, there's no valid ending state of a game where the first player wins. And as a result, the second player always wins. And so now basically what we have, since the second player always wins, no matter what either player does, the restriction that the game has to be optimal, where both players play optimally, is not that important. What is important is that the total number of games possible. Since either way, the chance that player 2 wins is 100%, and the chance that player 1 wins is 0%. So any move that either player makes will be optimal. So now basically the question is so if you didn't know this before, you should try to solve the problem from here. But now what the question is asking is how many possible games are there? So, and the way you solve this is you can solve this with basic combo. So consider you have some ending state with x turns. So you have valid ending state with x turns. Then you can take the number of ways to reach that state and multiply by x factorial. And that would be the number of games to reach that state. Another thing to notice is that every possible game that ends will be between, x will have to be between n/2 and n. In addition, x has to be even. X is even within that range. And the reason is, if you were to have some like board, if you were outside the range, for instance, you can't have a valid ending state with only 2 nodes. So like A, B, you can still add a node here, or like anywhere. Also, x has to be even, as I said before, or else it's impossible to have a valid ending state with an odd number of turns. So x has to be even, and it has to be more than the ceiling of n/2. So for instance, for size 6, the minimum number of moves will be 4. So for example, A, B, and the maximum obviously is n, where it goes A, B all the way around. So basically how you would solve this is that you will loop for x between these two numbers, and for every possible x, you count the number of boards that have x turns. So how would you do that? You need to find some sort of formula. So given some number of x, you were gonna have, for example, if x equals 4, n equals 6, you can have something like A, B. And in between each, you can have at 0 or 1 empty cells. And because you know that there has to be 2 empty cells, you see that you have x possible areas where you can put an empty cell. So it's going to be x. So out of these x places where you can put an empty cell, you have to choose n minus x. So for example, this would so the combination for this would be 4 choose 2. And there's 2 ways, basically, there's 4 choose 2 ways to choose the 2 empty cells, for example here and here. So if you choose these 2 empty cells, then this would correspond to something like A, empty cell, B, A, empty cell, B. All right. So there's choose n minus x ways to pick empty cells so that there's any configuration with in a board of size n and there were x terms. However, there's another restriction in that there's another thing you need to consider given that the board is circular. And so if you were to only consider this, then that would basically assume that the first number is taken with a token. And so you also have to consider the case where the first cell, I'm assuming this is the first cell, is not the first cell is not taken. So it's an empty cell. So something like this. Right? And so for this case, now we essentially assume that the first cell is empty. Then we have everything else. So now we will have, there's one less place where we can choose to put an empty cell, and there's also one less empty cell that we need to add in. So in this second case, we will have x minus 1, choose n minus x minus 1. And so these are the two cases that you need to consider. And so our formula is going to look something like and so this will calculate the number of possible ending states with x turns and a board of size n. And also, you need to multiply this by 2. Because you can have, for example, this counts AB, but you can also have B, A, B, A. So you replace all the A's with B's, all the B's with A's, and you have another valid state. So that's why you need to multiply by 2. Now you have all the end states. And you need to calculate the number of optimal games. And so you have some if you have some end state, so I don't know, A, B, so you have X letters. The two players can play any of those letters in any order. So what you want is the number of permutations, which will be to play X tokens, X letters, and so that would be multiply X factorial. So this is the formula to calculate the number of possible games with X, where you play X turns and on a board of size n. So now you take this formula and you loop from the ceiling of n/2 to n, where X is always even, and you add them all up, and that'll be your answer. And one final thing is that this formula, I guess it wouldn't really work for this case where X equals n, because you have choose -1 here. So just one more thing is that for this part, if X equals n, then just do 1. So anyways, that's how you solve this problem. The main thing is that you have to observe that one player will always win no matter what either player does. So by optimal games, we really mean all possible games. And once you figure that out, it's a much simpler problem where you have to solve this combinatorics problem. Like, comment, subscribe.